But I guess if you stand back from the picture, there's essentially three mega trends that we see are powering digital transformation and Kong in that regard. And really it's all about cloud native, as we call it. So, the first one is, and I'm sure you're all aware of this, moving from virtualization to containers, to Docker, to OpenShift, to Kubernetes, etc., to get that flexibility and that movement at the sort of infrastructure level. If we come up a level, we see that applications are clearly changing. We used to have application servers and databases, and clearly that middle piece is fragmenting and becoming, hundreds of APIs and microservices, containers and controllers, etc. And then really the third mega trend is that multi-cloud is happening. I think everyone would ideally like to align with a single cloud provider, and some are lucky to do that. But, our customers are telling us that they have to deal with all these different cloud providers, and they have, on-prem hardware, etc. So they're not just betting on a single cloud provider. And of course, all of those three trends creates an interesting complexity. And so it could almost be said that the fourth emerging trend is decentralization. And we're going to hear from Brad about that today. A little bit of background on Kong, just in case you're not aware of who we are or what we've done. So you could say that Kong has excelled in its ability to address this sort of full API and lifecycle management requirement around APIs and having APIs at the center of your strategy. So whether that's through design, deployment, management, security, measurement, etc., Kong is the world's #1 API gateway that's in use today. So open source at its heart, and there's been over 250 million downloads of Kong. So that's where sort of Kong, you could say, rapidly spread through the market. And then since then, we've been on this big evolution journey. I mean, the company has doubled in size in the last 10 months, something like that. So I've been on board for 3 months. Brad's been on board for not much more. And it's just testament to Kong moving into this sort of full service cloud native connectivity company. And so really the secret sauce of Kong is to be independent of any platform, any protocol, or any approach that you're using to build your applications, so that you're not locked into a tech stack. Kong essentially runs anywhere and runs on everything, which really allows companies to embrace their own complexity. And so what that really means in a nutshell is that we help companies to innovate faster, we help them to capture new digital opportunities, and we help them reduce the cost and improve efficiency in their operations. Just to shout a few organizations that we're working with here, so organizations such as TAL, the insurer, National Australia Bank, Australia Post, Ubank, Commonwealth Bank, Qantas Loyalty. So if you interact with Qantas and your points, that all runs through Kong. In New Zealand, there's the likes of ASB, the New Zealand Stock Exchange, Bank of New Zealand, Transport for New South Wales. So we're seeing a sort of growth in government, and the likes of University of Auckland in New Zealand. So and all of that has happened rapidly in a short space of time. And so with that, I'd just like to introduce Brad. So I've actually worked with Brad for quite a number of years now, and he's a veteran, you could say, of the connectivity problem. He's spent time at BEA, worked on the first application server there, spent time at Tibco, at Accenture, he ran the Salesforce integration practice, and then subsequently he's held 3 APAC CTO roles at MuleSoft, at SnapLogic, and now at Kong. And so, with that, it gives me great pleasure to introduce Brad as our main speaker for the next 50 minutes or so. Over to you, Brad.
Thanks, Colin. Great introduction. Hello, everyone. And, just further what Colin said around, this journey of decentralization, this presentation is really only the first step and the start of that, because, as you could imagine, decentralization is the process that the journey that every organization is going through as they look for ways to innovate faster and to capture new markets. And to do that, they're breaking up the monolith, and they're starting to become engineering organizations themselves, become software led. So there's lots of topics to talk about. I'll touch on an overview of decentralization and an overview of Kong briefly in this session, given we only have sort of 45 minutes or so together. And then I'll give you a bit of a demonstration of Connect, just so we can sort of set that level bar of what is Kong, what do we do, and then I'll show you an overall sort of mud map of the bits we touched on today and some of the areas that we'll touch on in future meetups. And your guidance and feedback on which areas you want to look at first will obviously be significantly helpful to us. As Colin mentioned, every organisation is under pressure to innovate, and they're trying to all provide compelling digital experiences. Organisations are addressing this challenge through applications that are built with modern architectures, using things like microservices, containers, and managed through Kubernetes to provide that much needed agility within the organisation in order to succeed and to succeed at scale. And organisations break down monolithic apps into smaller services, or they build new cloud native applications and reusing existing services. So as you can see, from organisations historically, which was focused around bringing a small number of very large monolithic applications on premise, to now looking at ways to blow that up, to think about how do we find more agility in the business by being able to break down these monolithic processes and applications into smaller components so that we can scale them and be more agile in how we deliver them. And then going forward, how do you take that cloud native approach to building new capabilities as well as reusing existing capabilities across the business and across the broader API economy? And so for organizations who go down this path, they're rewarded with some very positive business outcomes. First is faster innovation. So they're able to innovate not only faster, but also keep the quality of innovation very high. And that's often been a very difficult conundrum to manage. Do you move fast and sacrifice quality, or do you keep the quality of the assets you build really, really high at the detriment to speed? And so finding ways to innovate and bring agility into the organization quickly with high quality becomes critical. Other things here around how do you respond to disruption? How do you reduce the cost base within an organization, and as well as increase the efficiency, as well as capturing new market opportunities? And a study that we did fairly recently suggested that 51% of the enterprises that we surveyed said that if they would fail or they would be acquired within 3 years if they're unable to keep up with the pace of innovation. So we as digital consumers and digital customers, we put a lot of pressure on every organization to be better and to deliver a personalized, seamless, exemplary digital experience. And that puts a lot of pressure on the IT departments across any organization to be able to deliver upon that promise. So as you go on this journey of creating modern distributed applications to provide that agility for the business, you'll find that the applications will start to consist of an increasing number of smaller and smaller services. As you start to break down those large monolithic applications, you adopt more cloud, you adopt more SaaS, you lean into innovation from an engineering-led perspective, you'll find that you'll start to see more and more ways to attach to components and data within the organization. You're also wanting to give your development community the ability for them to select the best technology, the best protocols, the best patterns, and the best infrastructure for them to build and to deliver their capabilities upon. And so you'll start to see more complexity grow inside of the organization. This decentralization and the increasing complexity and the required diversity of technology, platform, protocols, and patterns leads to an incredible amount of opportunity. The opportunity to innovate faster and the opportunity to innovate with far higher quality. And what we're seeing in the marketplace is that the modern enterprise is the organization that is embracing all of these factors, is embracing decentralization, is embracing the distribution and the complexity and the diversity of the tools, the platforms, the protocols, and choices of technology. And they're very much leaning into that to embrace the opportunity that comes from it. But there is more to it. There's actually 3 types of connectivity we see between all of those services as they start to proliferate across the organization. There's connectivity between applications, and that might be for the benefit of automating a journey, a customer journey, or an employee journey. We see connectivity within applications as organizations start to lean in more heavily to microservice-driven architectures. They're using APIs to stitch together smaller, fine-grained capabilities in order to deliver a new composite capability in a very rapid, very agile fashion. And we're seeing service connectivity at the edge. So organizations that are using APIs as products to deliver out to their business partners, out to their consumers, their development community, or simply just to embrace the API economy and participate within it. And so those three different connectivity types all have technologies which implements and underpins each of these. And those technologies are actually starting to get very diverse and very complex. We see edge API gateways fulfilling the need for edge connectivity. We see internal API gateways as well as ingress and egress controllers for managing that cross-application connectivity. And we're starting to see a rise in popularity around service meshes to manage the service-to-service connectivity and security within the app, so the intra-app style connectivity. And it's when you put all of these together that it starts to form the technology foundation for stellar digital experiences. Because the modern enterprise is going to have a requirement for all of this. When you're leaning into microservice-driven architecture and you're starting to lean into becoming a software-driven enterprise, mesh and serverless and functions start to mean a whole lot more to your organization and your developers. And you'll be wanting to connect existing applications within your organization and across many organizations and departments of organizations using the API gateways. And obviously organizations will want to be able to expose APIs as products for participation in that broader API economy. And so the top technology stack that you need to deliver the service connectivity across all of those patterns is starting to get very complex, because you want to be able to embrace the best of open source, the best of the technology brain power available, the best of the skill sets that are available. You'll be wanting to make platform and cloud and technologies decisions based upon things like economic benefit. Which cloud do you want to use today because you get the best features or functions or the best price value from that? And so being able to support existing and new patterns, all of the various different technologies and tooling out there today that the developers are learning and bringing to the table, empowering those teams to be able to deliver their best work and their best innovation, and to do that with an automation first mindset is critical to the modern enterprise succeeding going forward. And so as you can see, the qualities of organizations differ from historically what was a very centralized view of applications, a very centralized view of an IT organization, to something now that is very distributed. It's completely diverse and it's very dynamic, and it's designed to embrace all of those technologies and to do that in a completely automated fashion. And so the organizations who are moving on that journey to the qualities on the right are the ones that are finding they're liberating that level of agility and service connectivity that they're required to be successful. So here are the things that we at Kong think are critical for you to be able to deliver upon this decentralization and the journey to decentralization as you go on it. And so there's end-to-end service connectivity across those three patterns that we mentioned earlier. You need to have support for architectural freedom. Developers can choose the right languages to build the right pieces they need. The best protocols, perhaps GraphQL makes more sense for some APIs than just plain REST does. Perhaps an event-driven architecture makes more sense. So the requirement to be able to support all of that. The requirement for hybrid and multi-cloud. Where does this stuff get to deploy? Do you deploy this microservice in GCP for the AI benefits and machine learning capabilities that perhaps are better serviced up there? Or are you deploying some of those capabilities into Azure because you're more of a Microsoft-led organization? Or perhaps both, or one today and a different one tomorrow. Most organizations are looking at ways to use containers for Mesos or Kubernetes style orchestration environments. So how do you embrace all of that technology? And how do you do that in a way that is not only native to those tools, but very natural to the users and the operators of those tools? And of course, performance, scalability, throughput, and elasticity become qualities that any organization wants to be able to deliver in the modern decentralized environment. Extensibility, the ability to be able to make products do more and to bend and flex with the shape of the business and the requirements of the business rather than being rigid and fixed. And what I believe is probably the most important piece around all of this, which is automation. You can't do all of this if the complexity of the IT landscape and the IT substrate is increasing, and the decentralization of it is increasing, and the adoption of tools and languages and platforms and protocols is increasing. You won't be able to move fast enough with manual processes. The only way you'll get the level of agility at the level of pace and scale that you need is if you automate your way through this. And so obviously there's a very large requirement for decentralization for platforms that deliver these pieces to be able to do it in a modern automated first approach. And so that's Connect. Connect is the platform for Kong that delivers all of that. It embraces all of those technologies, platforms, tools, and protocols. And it allows you to deliver the end-to-end service connectivity across edge API gateways, across ingress and egress controllers, across service mesh style architectures, within any cloud, across clouds, multiple and hybrid clouds, and to be able to do that in a highly performant fashion, in a very extensible manner, and most importantly, fully automated. Fully automated in a way that's native to those tools and platforms that we spoke about earlier, and automatable in a very natural way. To give you an example of what I mean by that, if you're deploying your microservices using Docker containers, or you're deploying into a sidecar-based architecture in a service mesh and using Kubernetes to orchestrate that, then the way you want to automate that particular part of your organization is with Kubernetes. And that's a very declarative, very GitOps style automation model. And so Kong natively interfaces with those tools and naturally feels normal and natural to the operators of those environments. And so we're able to help you embrace all of your complex IT estate in order for you to continue on that journey to decentralization. And so I want to stop there with the slides and give you a bit of an overview of some aspects of Connect, to introduce you to Connect and to show you what it's capable of today at a very high level, knowing that in further webinars we'll be going into deeper aspects and various different pieces of some of the technology I mentioned earlier. Okay, so let me log into Connect. Connect by default provides us with this web-based or SaaS-hosted control plane. And so when you first log into Connect, you'll see what's shown here as a service hub. The service hub here really is the service catalog. Every single one of those services that I mentioned earlier, whether it's a microservice inside of Kubernetes or a product-led API that you're delivering through an API gateway, or APIs that are exposed by your applications or various SaaS applications that you're embracing, can be registered inside of Service Hub. The goal here is to be that catalog of all of the services to give you a level of visibility and control. And so we'll go ahead and we'll create a new service and show you what that looks like. Also in here, there's this concept of connections. So, the community you're going to start building around developers and users and consuming applications of those various different services. Developers will get registered in here. There's this concept of a developer portal, and I'll show you what one of these looks like as well. So if you have APIs that you're developing that you wish to document and make discoverable to other users within the organization or other developers across the organization, or publicly exposing out to the broader API economy for people to discover and consume, then a developer portal is the industry best standard way for delivering that. And so for some or all of those services that you deliver here in Service Hub, you'll be able to document and deliver those as services. And then there's this concept of runtimes. So whilst this control plane component here that I'm showing you in this form is SaaS hosted by Kong, you can have runtimes, be it API gateway runtimes, ingress controller runtimes, or sidecar microservice driven mesh runtimes. You can have them all eventually registered for to be managed and controlled and secured and protected inside of the Kong environment. And so that's what I'm going to do first. I'm actually going to create a runtime on my laptop here and attach it with this Connect control plane so that we can start to play around. And so it's really easy to configure a new runtime. I'm going to go with the quick start Docker setup here because, as you can see, I've got Docker running on my Mac. You do have options to take this as standalone images that you can deploy to various different operating system environments. You can also take this as a Kubernetes style environment where you can just declaratively add the Kong runtime into your Kubernetes pod. So what I'll do here is I'll just copy this script onto my shell here. And what this script really does is it pulls down the latest version of the Kong runtime and will install it in a Docker container on my machine and register it back with the Kong control plane. Okay, so let's run that. You'll see that it will run a few checks. It'll pull the runtime down. We'll head back to our runtimes here. And when this is finished, what we should see here is a new runtime appear inside this environment. This is showing a few because every time I do it, I have a dynamic external IP address, so it sees it as a different runtime on my laptop. So there we'll see a new runtime that has appeared and is now visible and managed with Insider Connect. So that's really easy. First step here is we're going to add a new service. So I'm going to create a new service here and call it Pet Store. As you can imagine, I'm just going to reuse the Pet Store API that you can easily find out on the internet. Version 1, and give it a name. Click create. So what that does is it creates an entry in my service hub as a Pet Store API. There's no metrics or anything analytics associated with the API yet because we've just registered it. We haven't tied it to any particular backend implementation, and obviously there's no traffic going through here. As you can see, you can have multiple versions of this API running at any particular time, and you get full support for the API lifecycle associated with that. What I'm going to actually be calling here is a backend service which exists out on the internet, which is that Pet Store API. So you see here, I'm actually on the command line just going to call that API, and it's going to return all of the pets available in this store for sale at the moment. And so when I call that, that's going to be going directly to that Pet Store API out on the internet and coming back with a list of available pets. That's the URL I want to, or the API I want to proxy through my API gateway here for management and control. And so in order to do that, we're going to register that as a version implementation. That API already existed, but if you were taking a design first approach to APIs and you were building this from scratch, then you'd probably be using the Insomnia tool that we provide for doing that. Insomnia is that design first tool which allows you to build the Swagger specification and get visual validation of that specification on the right so that you can iterate through the design of that API before you think about how that gets implemented and deployed. Insomnia provides you with the ability to debug that API so you can actually go ahead and test it out inside of the tool, as you saw me do on the command line, to interact with it, and then you can build up various different levels of unit tests around that for testing of that API inside of Insomnia as well. Insomnia is fully automatable, so you can synchronize this with Git. Obviously, there's a repository, but underneath all of this, there's an insto command line tool so that using your CI/CD tools, you're able to do everything you can pretty much do from a development perspective inside of Insomnia, you'll be able to do on a command line level in an automated fashion as well. So let's go ahead and add an implementation for that version 1 of that API. So I click on version 1, and you'll see here I have the ability to register a new application as well as upload a spec if I have one. So I'll go ahead and create a new implementation, and I'm going to copy in that URL for that pet store, which we tested on the back end. There are a whole bunch of other options here. You can configure if you're turning on TLS and if you want to configure it with various different timeouts and retries. I'll just accept the defaults for this. And so that will register that upstream service as the implementation for this API proxy that I'm registering in Connect. And now I register a route. So you can have multiple routes pointing to multiple different implementations of services. Here I'm going to call this route Pet Store, And I'm going to leave everything by default. You can obviously specify specific hosts or specific protocols that you want to have support for, specific HTTP methods that you want to support or disallow, and then you specify path. So I'm going to give this one a /pet store. And basically what that means once it's created is that if I was to go to my laptop here and call that same service again, but do it through localhost, I think I've got this already running somewhere, I'll just copy and paste it. So here you see that I'm calling localhost port 8000 where my Kong gateway is running in the Docker container. I've got a route here of /pet store, and then I'm calling the same string that we call the backend service with directly. And when I do that, you'll see, sorry, I cut and paste a little bit too much there. You'll see that it will call the backend service and we'll get that same response coming back. Now, if we scroll, to make this shorter, I'm just going to pick one particular pet out here so we can see some headers. So I'm going to call this particular one. And so that will return just that particular pet ID, which is a dog. And so you can see here that the Kong has added some headers just so you can measure proxy latency as well as upstream latency. And it's just visual proof that this is actually going through that Kong gateway now rather than calling direct. I have a spec associated with this, so I can go ahead and update my my service entry here using the pet store YAML file that came out of Insomnia. And so what that will do is give me the documentation I need when it comes time to expose this API out through a developer portal. And so that's going to be our next step. We'll see that we have one service in here. We see some analytics starting to come through. I can hit that a few times just to start to generate a little bit more analytics. And you can see the latency is roughly about the same because this request is coming from my laptop to an API gateway on Kong on my laptop, off to that pet store backend on the cloud and returning again. So this is an API that I want to make discoverable. So I want to put this into a developer portal so that consumers of it can come and search for it, discover this API, understand how it works, test it and play with it inside the developer portal, read the documentation, and then hopefully want to use it. And so they'll want to be able to get registered access for that API and issue some API keys. And we'll walk through how that would work today as well. And so up in here, I would go back to my API that's running in my services. So we can see here in Service Hub, we now show that one pet store API. And I can click on here and say, the two bits I'm interested in is enable application registration, so that when developers come and request access to this API, I can specify how we will what sort of authentication we'll expect when people are registering for access. I'm going to pick key auth because it's easy for me to demonstrate, specify whether we auto approve that or not. And then I can go ahead and publish this to a portal. And so that service has now been published. If I was to head over here to the developer portal pane, you could see that there's one API which is being exposed through the developer portal, and we can go ahead and view that in the portal. So here I need to register to get access to the portal because, as I mentioned earlier, we provide this as a private developer portal. There is an option down here in the shared config in the settings where you can specify, where are we? So I'll pick the right page. You can specify here if you want to enable a public portal or not. I haven't. Quite often you'll find organizations will have a mix of both. They'll have private portals for APIs that they're just exposing internally to their own developers or to a community of managed developers. And you may also have a public portal where your public-facing APIs are exposed, and people may not need to register to use that. So I'm going to go ahead and sign up as a developer really quick. and create an account. And so that should hopefully send me an email, which I can use to, here it is, so confirm. So I confirm that. And then back here, you'll see in the connections tab, I have one developer that's requesting access to my developer portal. And so I'll go ahead and approve that so they can log in and get access to the developer portal. So once they log in, you'll see that they have access to my developer portal, and there's that one API that we've exposed a developer portal for. And so when I click on it, you will see that we've just rendered that same YAML file for interactive use as we saw inside of Insomnia when you were perhaps building and testing this API. So you'll be able to, search for various different pets, add new pets to the store, search by status. You can go ahead and try this out. Search for all available pets, and you'll see that will go ahead and call that API to be able to test it out and return this response coming back. So once you've understood a little bit about this API, perhaps the next step is to go ahead and register for it. Before I show you that, you can see here that there's lots of in the developer portal settings. There's lots of different things you can set up. So we mentioned you can set up a public portal. You can auto approve developers, auto approve those applications as we saw before. You can configure the appearance of the portal. And so you can change themes, you can add logos, you can change text colors and buttons and font sizes if you want. Inside of every particular service that you have registered, you can actually also upload Markdown. So if you wanted to define a whole bunch of documentation associated with a particular developer portal, then you can do that in standard Markdown and upload that here through this environment. I can go ahead and do that really quickly just to prove the way that works. I've got some Markdown I've created here, which is really just a link to an image. And so once I update that, you'll see if I refresh this developer portal, all it does is add an image at the top of one of the pets that we sell inside of the store. And so you can use Markdown to configure this developer portal to look the way that you want it to do. There's also support here for a portal CLI. So you don't have to do all of this through this Connect UI. You can obviously automate that through the back end using that portal command line tool as well. Okay, so as a potential user of this API, I want to get access to it. So I click register and I create an application. I'll call it my app reference. This could be my mobile application, which I'm building to allow people to view pets, to see their availability and to reserve them on their mobile device. So we'll click create. And so now I want to using that application that I've registered, I want to request access to this particular API, because as we saw before, we had the requirement to register for access to this API enabled. And so that pops up that button there. And then when I go back as a administrator of this API, you'll see that there's a request to approve that particular application for access to that API. So I'll go ahead and approve that. Now, when I go into the list of my apps as a developer, so I look at the catalog of applications that I have, you'll see my app was the one that I got access, I registered for access to that pet store service at the back end. I can go ahead and create a credential. And so I specified a standard API key. And so I've got an API key that's been registered here for calling that particular backend. So when we registered or published that API through the developer portal, we enabled that key authentication for people who want to consume it. So now if I was to try and call that API, you'll see that we get a 401 unauthorized coming back, because there is a policy that's been enabled on this particular service, and I'll show it to you. You'll see that there's a key authentication plugin that's been enabled, right? And so plugins, we provide a whole library of plugins that you can configure and apply to your services inside of Kong at the global level, so that all services inherit a particular policy. You can do it at the service or the service version level, and you can also do it at the route level as well. So if you want to, provide different policies at different levels of granularity across the services and versions of your services, and then routes of your services, you can do that in a very fine-grained fashion inside of Kong. And so in order for us to now access this API, we obviously need to apply an API key here to be able to call it. So if I copy that key, you'll see now as a registered user of that API, I can now call that API using that key. And that'll start to capture my identity through the analytics in the platform, so that it knows that it's me that's being called that, and you're able to capture that analytics and that consumption data and perhaps monetize it if you're charging people for use or calling of those APIs. You see, if I change something in the API key, it's not going to work. So that is actually validating me using a valid API key. You could be using OAuth, you could be using OpenID Connect, you could be using SAML, you could be using all sorts of various different authentication and authorization mechanisms to protect and secure those sorts of APIs. I just used a simple API key here because it was really easy for me to test. Some of the other policies that we provide that I can show you here. So if I was to add a new plugin, it'll take you to our plugin hub. You can see there's a whole bunch of plugins around authentication, whether it's authenticating against backend identity management systems or using various different protocols like OAuth, OpenID Connect on top of that, to be able to do some sort of more complex authentication, JOT and JOT signing, security. So there's bot protection, there's cross-origin resource sharing, there's restricting of IPs, there's all sorts of capabilities inside of there. There's a whole bunch of traffic control proxies. So you can see when we called this, you saw that the latency inside of the gateway was very small. And so it was sort of, 2 or 3 milliseconds, but the latency to the back end was much larger. And that's because I'm calling some sort of service which is out across my broadband and up in the cloud somewhere. And so one of the policies here we have is caching. There's standard caching, advanced caching, and there's some caching that we provide and rate limiting we provide around various different protocols like GraphQL. So I'll just enable proxy caching. There's lots of different things you can configure here. I'm just going to specify for the purpose of the demo that we're using an in-memory caching strategy and click create. And now you'll see that plugin appear down here. If I was to call that service again, it would go all the way through to the back end and cache the response. And you can see that the round trip latency is about the same because the first cache was a miss. The second time I call it, we got a cache hit. And so there was no latency to the upstream service because we're caching that directly inside of the gateway. And the response you see here is basically either 1 millisecond or even 0. It's negligible altogether. Some of the other policies available, there's rate limiting, for example. So you might choose to say this particular API in this example I'm using can only accept, say, 3 requests per minute. And you might choose to apply that on a route or a particular path of the API or a particular version of the API or on based around particular styles of consumers or groups of consumers that are using it. And so as you would imagine, once that's been applied, I'm a valid user, so I can call it up to 3 times. I've got an internal server error on that one, which is interesting. Let's have a look at that. There might be something I misconfigured. Rate limiting. Let's edit that one. I think I forgot to, I didn't have a cluster set up. So we'll just use a local coherency model for that one. And now when I call it, we should get a response. And you'll see there's some additional headers that are being provided here, which is around the rate limiting. So I can call that 3 times before I'll get a 429 too many requests. So there's an example of a rate limiting plugin that's in use there. And so, there's a whole library of plugins available here. Most of them provided by Kong. We do have some partners who build various different plugins for us, support for different serverless functions, support for analytics, support for transformations, and support for redirection of logging. Underneath the covers, this API gateway on Kong is very highly performant, and its architecture is based upon Nginx. So a very small footprint with a plugin-oriented architecture. So we provide a plugin development kit where you can build plugins using Go or Lua to do any sort of custom work that you typically want to do with inside of an API gateway, and you can have your plugins provided in this list here as well. And so if we go back to the very high level of Service Hub, you'll see that our pet store now starts to have some analytics associated with it based around the consumption of it. So we can see the requests we have and any failed requests, the number of versions that are provided. The analytics can also be broken down on a particular version basis as well. So these analytics, depending on your tier of usage of Connect, the data here can be held within the platform for up to a year, but obviously you have the ability to export that data. We also, through those plugins you saw before, have the ability to feed in real time the consumption data and the logs out to tools like Prometheus or Zipkin, or out to telemetry tools, or out to things like Splunk or Datadog. Or Sumo Logic for you to integrate with those various other tools and environments you have as well. Just to give you a bit of an overview very quickly on some of the automation aspects associated with this. We mentioned that the Insomnia tool has an INSO CLI, there's a Portal CLI. There's also a tool which we call Deck. And Deck is our command line tool to be able to automate all of the aspects of Connect and the API gateway in a programmatic approach. We also provide platform level APIs. And so there's APIs within Connect that you can call with different personas in order to do all the things you saw me do in that UI and to interact with the platform in a programmatic fashion. And Deck is really a CLI that's just leveraging those APIs. So the first thing I might want to do here is use Deck to connect to my Connect instance and to dump the configuration. And so what that command there is actually doing is producing a YAML file, which is a declarative representation of the configuration of Connect. And so you see in here, I have my pet store API, there's one version, there's all of the attributes and configuration aspects associated with that. So using my automation tools and my CI/CD pipelines that I might have in place, I would potentially be able to create a new API using the tools which edits this particular file, which I would then install in GitHub for versioning purposes. So I might call this my new API, and I might give it a description of this is a new API. I won't give it any other configurational aspects other than just registering it as a new service with that as the minimum. And so when a new API gets developed by a team, the configuration of it inside of Connect can be injected into this YAML file. You pull it out of GitHub, inject this into their version control, you get diff management, you get support for all the different versions of it, and then you can sync that back with your Connect instance. So when I do a sync, that will actually do a diff and make sure that I'm able to update that information inside of YAML, inside of Connect, sorry. And then back here in Connect, a refresh here. I just got a timeout. Let me just log back in again. You'll see I have two services. I have the pet store and my my new API. The existing one here we have pet store API. I can put, just to make another quick change for you here, I can, put hello world there, and you'll see when I sync, that will dynamically change that information up here inside of Service Hub. And so this Deck tool will show you what's going on and the changes that are being made. And here you'll see that this number changed here from pet store API to pet store API hello world. So lots of tools, lots of APIs, lots of support for automation of everything that we've seen here. If the API gateway that I'm running here in Docker happened to be a sidecar that was running as a data plane inside of a mesh to manage a microservice, for example, and if that was in Kubernetes, then I would use kubectl to do a similar sort of thing. I would configure Kong and the services that were being provided and the configuration of the services that were being provided for that particular microservice. I would use GitOps practices, and I would use a declarative approach to how I would configure and manage those using kubectl rather than using the deck tool here as well. So as I mentioned before, the way you automate, the way we interact with those technologies are native to those tools, as well as very natural for the operators of those tools. So that's it. We're running very short on time here, and we're getting close to the end. But if there's any questions, then now is a good time to take those.
Yeah, please feel free and enter your questions in the chat or speak up if you'd like to as well. We have a smaller group, so you're welcome to speak up.
Yeah, Brad, there's no any specific question because from my side, it was my first, means I have touched API gateways earlier, like API gateway in AWS or API that was majorly I touched, and but I was curious to see, how this Kong, this connect, which have API gateway proxies, plugins, and everything, it works. So and that is really a very good for me. It really helped me a lot to understand this this thing. So one of the question is in the plugin, as you said that in the plugins, most of the plugins developed by Kong or your partner. So do you follow a system? I'm sure you would follow a system where your each plugin actually validated well before it enters, or it has like or means how it can be, how it means. So you have some system where you validate those plugins and then it enters to the enters to this ecosystem.
Yeah, so obviously, so there's plugins that we build and provide, and that's the vast majority you're seeing here. There are some, if you go further down, actually, if you head to the docs, let me just bring up the plugin hub here, because this will show you a more broader list. I think it's hub. Let me just do a search for plugins. Plugin hub, here we go. Oops, that's the one for TLS. Here it is. You'll see that these ones who supports us. The stuff we build, we obviously provide enterprise support for. But if I scroll down to some of these other ones here, you can see that the Okta one is supported by Okta. So okay. We'll support them. The ones in here we do provide support for, but they may be plugins that have been built by a partner or a third party. We provide a plugin developer kit that's based both on Lua, which is what sort of OpenResty and Nginx is leveraging in our underlying tech stack, as well as Go. So our professional services team, or even yourselves, if you have the capability in those languages, can build your own plugins that can be supported and managed by yourselves. So we obviously can't just take anyone's plugin that anyone's developed and put it up here in the hub and say we support it, because we don't know the quality of it. But ones that tend to be most popular and most useful tend to make their way into a supported fashion, just because they become useful for multiple customers.
Okay. Yeah. Thanks. So mostly this solution mostly is for that kind of solution where the API is exposed to the public.
Not always, no.
Because
you could imagine if you
sorry to interrupt. So there are multiple cases, few cases which coming in my mind. One case, like in any full stack product engineering where there are tens of microservices and they are talking with the web UIs or mobile UIs, but that is closely because the thing exposed to the public, it is the UI. And yes, that is good what you have shown. It is, if we can have better management of APIs, better management of cores or cores or anything which can give trouble to API if we don't manage it, whether it is internal management or whether is any threat which is coming from outside. So one part which means one thing you have explained well, that how it can be automated, managed well when we have sets of microservices, but this automation can help to have better development within a team and all. But another question is, I would like to know, let's say we can manage by ourselves, management is going point, how it can help us on those applications where we have exposed UI to the public, in terms of let's say LinkedIn platform or any major platform where how if anyway this solution can help if our APIs are in trouble. Am I able to explain well?
Yeah, and because the nature of the audience and the sort of problem space you're looking at will differ from APIs that you're exposing publicly and have developer, sort of human level developers that are building applications to access it. And so you care a lot about identification and authorization and authentication. Yeah. You care about the quality of traffic. So if they're paying customers, they might get a higher tier of or quality of service than free customers, and protecting against the sorts of threats you'd expect to see from the public, like bot attacks or denial of service attacks and things like that. When they're microservices deployed in a mesh, you care more around sort of mutual TLS across that estate. You care about things like Canary, as shown on the screen here, where when a new version of a microservice is rolled out, how do you start to divert small pieces of traffic across to the newer version to test it out, or certain consumers to the new version to test it out before you do a broader shift of traffic along the way. Or you might be nailing down microservices with access control lists, or and saying this microservice will only ever talk to these other 3 microservices rather than the whole estate. So I understand what you're saying, and I'm just saying that there's policies here that will work and be more useful for one audience versus the other, and some for both. It really depends on what the problem space is.
But it is so it's like, do you have some data or some kind of anything where you can, because let's say in some project we do not have that experience once we deploy into the public domain. So API may get threats or API may get in trouble, which we have not thought of. So because of that trouble means which is just theoretically we know, but or we will know once that any threat actually will come. So do you have such comments and data for that which we can consider for now?
Yeah, so I'm trying to find something here for you. So if you lock it down too much, it becomes impractical, right? And people just find it too hard to discover and use your API. So you want to be able to make it really easy for them to discover and to use it. But you're right, you also want to protect against that. And so most organizations will do that by forcing people to register for access to the API, issuing them with a key or some mechanism or some token so that you can identify them and only they can call it, producing different qualities of service tiers. So saying, look, I'm going to let you use it, but I know you're only playing with it for the time being. It's a sandbox, so you get a limited amount of capacity or limited amount of throughput or calls to protect you against an overload of someone just suddenly performance testing or benchmarking your API when they're not, a valid customer for you, as well as allowing paying customers a higher level of customers to be able to interact with it. And then you will see there's some threat protection policies here. Let me just find them for you. These guys here. And so there's some out-of-the-box policies to do bot detection to help. So if these events start to come up, you're able to see that and be notified by it through these policies. And so There's approve API. So some of these are external third parties, but we can take the request that comes into your API and through this plugin, validate it or do some sort of third party check against these platforms like Approve or like Salt Security or Signal Sciences or Wallarm or whatever. And they have a lot of AI-led and machine learning-led style validation and threat protection tools that you can have the calling path call before you respond through your API. So integration with them is quite often a really easy and cheap way for you to protect against what you don't know, which is, you don't know what the threats and the shape of the traffic for a new API looks like if you've never done this before. So there's lots of ways we can help you there.
Yeah, thanks, Brad. It's really helpful. Thank you so much.
Pleasure.
Yeah.
So just to finish this off really quickly, what I showed you here was, oops, wrong button. What I showed you here was just a piece of the broader Connect platform. We saw Service Hub, Runtime, and we talked with just the gateway component. Obviously, there's also the support for mesh and the support for Kubernetes ingress controllers. And I did this all on my laptop. I didn't show you any of this running with a Terraform script or any of this running on any of these cloud providers, but that's part of one of the future meetups that we will have. We talked a little bit about automation. And so as we saw before, there's APIs and command line tools to give you full end-to-end automation in a native and natural fashion. And we call that API Ops. And we have a really strong opinion and differentiation around how you should use API Ops to enable automation. And so with that, go and fill your boots. You can sign up for Connect for free and get using it and playing with it and do much of what I've shown you today. We have a new tier called Plus, which we've just released, where you can, if you want to start using it for real inside of your organization, swipe your credit card and get busy with it and pay as you go. And then for organizations that want to know more and are thinking about using some of this sort of technology more strategically and broadly across your organization, come and have a chat to us because there's lots to talk about. So unless there's any other questions, I know we're at time. Thank you very much.